In problem number 25, we are asked to find the antiderivative of the function f of x equals to 4 divided by square root of x, satisfying the condition that the value of the antiderivative at x equals to 0 equals to 1. The original function is denoted by lowercase f of x. Its antiderivative is denoted by capital letter f of x. So the fact that capital F of x is the antiderivative of the function lowercase f of x simply means that the derivative of the capital F of x equals to the lowercase f of x. First, let's determine all antiderivatives of the function f of x. We will integrate the function that's given to us, 4 divided by square root of x dx, to find all antiderivatives of this function. To integrate this function, let's rewrite the term of our function, 1 over square root of x. Let's rewrite that as a power of x. Square root of x is x to the power 1/2. And considering that it is in the denominator, we can rewrite 4 divided by square root of x as 4 multiplied by x to the power negative 1/2. Four is a constant factor. We can move it outside of the integral by the constant rule. And to integrate a power of x, in this particular case x to the power negative 1/2, we can use the power rule. The power rule says that the antiderivative of x to the power n equals x to the power n plus 1 divided by n plus 1 plus an arbitrary constant of integration. In other words, to find an antiderivative of a power of x, we need to raise the exponent by 1, divide by the new exponent, and add an arbitrary constant. So if we do that here, we will get 4 times x to the power negative 1/2 plus 1, all divided by that new exponent of negative 1/2 plus 1, plus the constant of integration. And negative 1/2 plus 1, that's positive 1/2, x to the power positive 1/2, looking at this term right here, x to the power positive 1/2 is going to be square root of x, and then 4 divided by 1/2 is going to be 8. And so we get 8 square root of x plus an arbitrary constant of integration. This is a formula that includes all antiderivatives of the function 4 divided by the square root of x. We, though, need to identify the antiderivative which satisfies an additional constraint, namely that the value of the function at x equals to 0 equals to 1. Let's plug in x equals to 0 and set the value of the antiderivative equal to 1, and then solve for c. So the value of f at x equals to 0 must be 1. On the other hand, it's going to be equal to 8 square root times square root of 0 plus c, and therefore this tells us that the constant c must equal to 1. Therefore, the formula for this antiderivative is f of x equals 8 square root of x plus 1. Finally, let's plug in x equals to 16. The problem is asking us to calculate the value of this antiderivative at x equals to 16. Plugging in x equals to 16 gives us 8 times square root of 16 plus 1. Square root of 16 is 4. 8 times 4 is 32 plus 1, 33 is our final answer.